Hi, I am Amni AMALINA binti ZAMZIHAR from JCDCS 1103E.
Hi, my name is NAZLAH binti RADZI and I'm from class JCDCS 1103H.
So, let's start with the introduction. The application of differentiation in solving maximum and minimum problems is a fundamental concept in calculus, often referred to as optimization. This process involves using derivatives to find the critical points of a function, which are the points where the function might achieve its maximum or minimum values.
Optimization. It is the process of finding the best solution among a set of possible solutions. In calculus, optimization often involves finding the maximum and minimum value of a function.
So, let's move to strategy to solve the problem. Step 1. Define the problem and variables. First thing first, you need to identify the objective. Clearly state what needs to be maximized or minimized. This could be profit, cost, area, volume, and others. Then, you need to define variables. Identify all relevant variables and parameters involved in the problem. For example, if maximizing profit, variables might include the number of units produced or sold. Then, lastly, you have to establish constraints. Note any constraints or limitations, such as limited resource or budget. Step 2. Formulate the optimization equation. First one, you have to express the objective function. Write an equation that represents the quantity to be optimized. For instance, if maximizing profit, the profit function might be expressed as P in bracket X equal to R in bracket X minus C in bracket X, where R in bracket X is revenue and C in bracket X is cost. Then you have to use constraints to simplify. If there are constraints, use them to eliminate variables and express the objective function in terms of a single variable. Step 3. Find critical points. First one, you have to differentiate the function. Find the derivative of the objective function with respect to its variable. This derivative represents the rate of change of the function. Then you have to set derivative equal to 0. Set the derivative equal to 0 to find the critical points. These are the points where the function might achieve its maximum or minimum. And lastly, you have to solve for the variable. Solve the equation from the previous step to find the values of the variable at the critical points. Step 4. Determine maximum or minimum. First one, you have to use first derivative test. Examine the sign of the derivative on either side of each critical point. If the derivative change from positive to negative, the critical point is a local maximum. If it changes from negative to positive, it is a local minimum. Then you have to use the second derivative test. Find the second derivative of the function, and then you have to evaluate the second derivative at each critical point. And lastly, if the second derivative is positive, the critical point is a local minimum. If it is negative, the critical point is a local maximum. If it is 0, the test is inconclusive. And the last step is step 5, interpret results. First one, you have to check practicality. Ensure that the solution makes sense in the context of the problem. For example, if the problem involves producing units, The solution should not involve negative numbers of units. Then you have to consider endpoints. If the domain of the function is restricted, check the endpoints as potential maximum or minimum points. Then lastly, global versus local optima. Determine if the found optima are global, which is best overall, or local, which is best within a certain range.
Boss. I want to give the report for this month.
Oh, thank you. Not bad, but I want to know the maximum profit that we could make. Can you do it?
Okay, boss. Right away. Okay, thank you.
Now, let's solve it. A company produces a product with a cost function given by Cx equals to 2x power of 2 plus 10x plus 100, where x is the number of units produced. The revenue function is given by Rx equals to 50x minus x power of 2. The question is, find the number of units that maximize the profit and calculate the maximum profit. First, we need to define profit function. The profit function Px is defined as the difference between revenue and cost. Px equals to Rx minus Cx. Then, substitute the given function and simplify it. After that, find the critical point. We need to differentiate Px with respect to x. Then, set Px equals to 0 to find critical point and solve it. Then, we need to determine maximum or minimum. Use the second derivative to test. If the value is less than 0, it means that 20 over 3 is the maximum value. Lastly, calculate the maximum profit by substitute 20 over 3 into Px. Therefore, the maximum profit is achieved when producing 20 over 3 units, and the maximum profit is 100 over 3. This question demonstrates how differentiation can be applied to find the maximum profit by optimizing the production level based on cost and revenue function.
Boss,
Yes.
the report, I've done a calculation and it seems like maximum profit we can reach, which is 100 over 3%.
Sounds good. Okay, thank you.
Welcome.
Apply maximum and minimum problems. Use calculus to optimize real-world scenarios, such as profit maximization or cost minimization. This method helps identify the critical points, then optimize the objective function and confirm their nature using the second derivative. The process is practical for solving a wide range of problems in economy, engineering, and management.
That's all from us. Hope you enjoy the video and don't forget to like, subscribe and share.